So what about temperature altering it? So it turns out that you can use Le Chatelier's principle to predict which way temperature changes a reaction. We'll talk later on when we talk about free energy and entropy a little bit more about another way to think about this in more mathematical rigor. But a very good way to shorthand think about it is think that if a reaction is endothermic, you need energy input. You need to input heat for the reaction to happen. So increasing the temperature adds heat, which increases the reactants. And so therefore, increasing temperature for an endothermic reaction shifts to product. Decreasing the temperature shifts it to reactants. So here, let's visually look at this. So here we have an endothermic reaction. If you have a carbon dioxide plus an amount of energy, you can split that apart into carbon monoxide, and this is not balanced, but you can balance to carbon monoxide and oxygen. So here it's endothermic. You could think of energy as an input. So at a certain amount of time, we decrease the temperature. And what we've done is we have removed one of the reactants. If we've removed one of the reactants, then it goes and makes more CO2. It makes more of the reactants and less of the products. So that's what you think of it. If you just put heat as the energy input, the heat as either a reactant or a product, then you can use Le Chatelier's to predict which direction it's going to go as well. What about if it's exothermic? Then one of the products is heat. Exothermic reaction produces heat instead of takes it as an input to make happen. So increasing the temperature adds heat, which increases products, which means that increasing the temperature for an exothermic reaction shifts it to reactants. Decreasing the temperature would shift it to products. So again, here we've got an exothermic reaction. We have sulfur dioxide reacting with oxygen to produce sulfur trioxide, and energy is an exothermic reaction. So if we decrease the temperature here, we have decreased one of the products. If we've removed product, that means we shift it to move forward. The concentration of sulfur trioxide increases and the concentrations of the reactions decrease. So the key to this is just look, is it exothermic or endothermic? Figure out whether energy, thermal energy being put in is a reactant or a product, and then do that.